As we have explored Spark Structured Streaming APIs in detail and also understood the development as well as deployment lifecycle, now let us review details about output modes and sinks. Output modes and sinks are very, very important, and hence I'm reiterating here even though we have covered earlier. Now let us go to the official documentation and try to understand the concepts behind this. So as part of the official documentation, you should go to basic concepts, and you can see there is a data stream and unbounded table. So in this case, the input data stream is nothing but an input table. If you actually relate to our code, which we have developed, lines is nothing but input table, which actually get the messages in streaming fashion at every trigger interval. And then once we submit a query on this input data, it will generate something called result table. Every trigger interval, new rows gets appended to the input table, which eventually updates the result table based upon the query that is being run against the input data. Whenever the result table gets updated, we would want to write the changed result rows to an external sink, which can be a file or a database or whatever target you want to write to. That being said, in this case, the department traffic is the final result table, and we are trying to write it using write stream onto the console to just see the end-to-end streaming pipeline in action as part of the demonstration. However, when it comes to actual production implementations, we typically write it to database or files. That being said, you can actually see the pictorial representation of how the data will be processed. You can see that there is data up to t equal to 1. So this is only the first few records, and whatever query or logic implemented on that will be applied, and we'll see the result, and we will be writing that output to some external storage. It can be complete mode or append mode or update mode. There are few restrictions which we'll be seeing later. As part of this picture, they're actually using complete mode. That being said, when data is retrieved by interval 2, we have both data related to 1 as well as 2, and you can see the results for the entire data, and we will be again writing it to the external storage. Same is the case with data up to trigger 3 or trigger interval 3. We will get the results up to trigger interval 3, which will be returned to the external storage, in this case using complete mode. So when it comes to complete mode, append mode and update mode, the entire updated result table will be returned to the external storage if you use complete mode. If you use update mode, only those rows that are changed since the last trigger will be returned to the external storage. When it comes to append mode, only the new rows appended in the result table since the last trigger will be returned to the external storage. However, the data should not be processed using any aggregation operations. If you have any aggregations, then the append mode will not work. When you have aggregations, either you have to use complete mode or update mode to write data into the external storage. With respect to complete mode, the entire results table will be written in each trigger, whereas with update mode, only the updated rows since the last trigger will be written to the external storage. That being said, we can scroll down further and we can look at this picture, which will give us much better perspective. You can see that as part of the first trigger, we got 2 records, cat, dog, dog, dog. Data up to t equal to 1 is nothing but cat, dog, dog, dog. And then there's a word count logic implemented on top of it, and hence the results for this t equal to 1 input data is nothing but cat is 1, dog is 3, and that will be written to the external storage. When it comes to second trigger, we have owl and cat, but as part of the first trigger, we already got cat, dog, dog, dog. And this will be appended to the input table like this internally, and the result will look like this: cat, dog, 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 owl, cat. This is the data up to 2. And then when we apply word count example, we'll get cat as 2, dog as 3, and owl as 1. If you say complete, we will get all the 3. If we say update, we will get only cat and owl, because dog is not updated since the last trigger, and hence dog will not be printed on the screen or returned to the external storage if we use update mode. But with complete mode, we will see all the 3. Now comes the third trigger, where we have dog and owl, and the entire data will look like this. And then the results will be cat is 2, dog is 4, and owl is 2. If it is complete, we'll see all the 3 records. If it is update, we'll see only dog 4 and owl 2. We'll not see cat 2. That being said, even though you feel that data is being processed like this, between the triggers, it will not pass the source data as is. It will actually keep the aggregated results, and then you will get the new records, and then using the previous aggregated results and the new records, it will aggregate once again and it will generate the results. It is very important to understand. You can see here, note that structured streaming does not materialize the entire table. It reads the latest available data from the streaming data source, process it incrementally to update the result, and then discards the source data. It only keeps around the minimal intermediate state required to update the result. It will not keep the entire source data to get these aggregations done over a period of time. It will be overkill if it does so. That being said, this might lead us into some issues such as late data and all. We will understand how the late data is handled using Spark structured streaming. As we have understood the details with respect to complete, append, and update as output modes, now let us talk about sinks. When we talk about external storage, it is nothing but a sink, and the different external storages or sinks that are supported out of the box with Spark structured streaming are nothing but file, Kafka, memory, console, foreach. For all these four, we can use format as the API, and we can pass the file format or memory or console or Kafka related details along with options to write data to external storage. With file, we have path and checkpoint location. With Kafka, we have Kafka bootstrap servers and topic to which data should be written to. With memory, typically we don't use any options. However, we use query name so that we can register a query and we can run queries against that query name. With console, again, we don't use any of the options. We just want to see the processed results on the screen. The most common use case apart from file when it comes to writing data from the result table to external storage is to write to database. For that we use foreach, and as part of foreach we need to pass a writer object of type foreach writer, and then we have to provide implementation for open, process, and close, which will take care of establishing the connection for each data frame or RDD partition. Process the data. Once the data is processed for each partition, then the connection will be closed using the logic that is implemented as part of close. We'll not be seeing that here, but as part of the final demo, we will see how to write the result table into HBase using foreach writer object. However, when it comes to output modes and sinks, they have to be compatible with each other. Only if they are compatible with each other, we will be able to see the results as expected. Otherwise, you will start seeing the exceptions that you cannot use append mode in this case, you cannot use update mode in this case, or complete mode in this case, so on and so forth. That being said, you can click on this link where we get the details with respect to compatibility between sinks and the modes. If it is file sync, we just have to use append mode. We should not use complete or update. If it is Kafka sync, you can either use append or update or complete. If it is foreach sync, again you can use append or update or complete. Same is the case with foreach batch sync. Foreach and foreach batch is almost same. When it comes to console, again you can use append, update or complete. However, if you want to use memory, either you can use append or complete. You cannot use update mode if it is memory sync. So it's very important to understand this mapping so that you can actually use appropriate output modes with the sinks you are trying to use to write the result table to the external storage.